All right, 2.1. We're going to talk about functions, more specifically, domain of a function. On the second page, it talks about certain rules that we have to follow when finding the domain. So if there's a variable in the denominator of our fraction, we set the denominator not equal to 0 because we can't have 0 in the denominator. Remember, if we have 1 over 0, this would be undefined. If there's a variable under a square root, we set the expression under the root greater than or equal to 0. Again, because we can't take the square root of a negative number, so it has to be greater than or equal to 0. If we had the square root of -1, what is that? What's the square root of -1? Imaginary, I. It would be I. So it would be not a real number. So that's why we have to set whatever is under the square root greater than or equal to 0. And if there's a variable under a square root in the denominator, we set whatever's under the root greater than 0. Because if it's in the denominator, it can't also be equal to 0 because we can't have 0 in the denominator. So these are the three cases that we have to look out for. If none of these things happen, if we don't have a fraction, if we don't have a square root, then our domain is going to be all real numbers. How do we write all real numbers in interval notation? Awesome. Negative infinity to positive infinity. So in example 7, we're finding the domain of each function. So if we have a fraction, we said that our denominator cannot be equal to 0. So we set whatever's in the denominator not equal to 0. So for A, I'm going to do it on the side over here so we have more space. We need to find out what value of x do we have when x squared minus x does not equal 0. So we're kind of just solving as if it is equal to 0, but it's just those are the functions where the numbers that it doesn't work, the values. How would I solve here? How do I solve for x? Awesome. If I have an x squared and an x, I know that I'm going to have to factor, and I'm going to factor by taking out the GCF. So I take out an x, and what am I left with when I take out an x? X minus 1. Awesome. So this does not equal 0. So how do I find the values of x where it does not equal 0? What do I do next?
Distribute? No.
Set each one not equal to 0. So same way we would do when solving. Instead of equal 0, does not equal 0. So x doesn't equal 0 and x minus 1 does not equal 0. So one of our values is going to be 0. The other one, I'm going to add 1 to both sides. So x does not equal 1. So these would be our two values. Now we have to write it in interval notation for our answer. So let's put them on a number line just to see what it'll look like. So we're talking about all values except 0 and except 1. So this gets shaded, everything up to 0 and everything up to 1 and past it. So in interval notation, how would I start? What's the smallest value that my graph points to? Awesome. Negative infinity. Where does my graph stop? No, we have a gap here at 0, so it stops at 0. Is 0 going to have a bracket or parentheses? Parentheses. Because 0 is not included. We're saying that x does not equal 0, so we have a gap at 0. It picks up again at 0 and goes to what? 1. And then it picks up again at 1 and goes to infinity. So you don't have to graph these. If graphing helps you with your interval notation, then graph it. But you don't have to graph. All you need is your interval notation. So wherever you have a gap where x does not equal that number, we have to show that we have a gap in the graph there. All right, let's look at B. So in B, we have a square root, a radical. We know that under our radical, what can we not have? Negative numbers. So we would set what's under our radical greater than or equal to 0, because it has to be all positive numbers. So I'm going to do that on the side over here for B. We have 9 minus x squared is greater than or equal to 0. So how would I solve for x here? We could do that, or what else could we do? Add x squared to the other side. Either way would work. So 9 is greater than or equal to x squared. We don't have x all by itself. What would I do next? Square root both sides. So square root cancels out the squared. What do I have to remember when I take the square root of both sides? Plus or minus? So what's the square root of 9? Plus or minus 3. Now let's put this on a number line to see where we're talking about. We're either going to be talking about in between -3 and +3 or outside. So what's a number that I can test in between? 0. Let's plug in 0 and see if it works. So I have 9 minus 0 squared is greater than or equal to 0. Is 9 greater than or equal to 0? Yeah, so we're going to shade in between. So for our domain, we're talking about values in between -3 and 3. Would I have an open or closed circle at -3 and 3? Closed. So how would I write this in interval notation? Where does my graph start? Bracket -3, and where does it end? 3. Perfect. So this would be our answer. Again, you don't have to graph it, but sometimes it'll help to graph it to see if you're going to shade in between or outside so you know which part you're talking about. So C, we have a square root in our denominator. So going back to the last slide, this is like example 3 that it says, situation number 3. What do I do when I have a square root in the denominator? What does the last slide say? I said it greater than 0 because if it's in the denominator, it can't be equal to 0. We can't have 0 in our denominator. So I set what's under the radical greater than 0. So I'm going to do it over here. So all I care about is what's under the radical. I ignore the rest of the equation. So I have t plus 1 is greater than 0. How would I solve for t? Subtract the 1 to move it to the other side. So t is greater than -1. So if it helps you, put it on a graph. This would be -1. Do I have an open or closed circle at -1? Open. And if we're talking about values that are greater than -1, which way would I highlight? To the right. All right, so how do I say this in interval notation? Do I put a bracket or parentheses? Parentheses -1 to infinity. Perfect. All right, let's take a look at D. So for D, do I have a fraction? Do I have a radical? So what's my domain going to be? What's my domain going to be? All real numbers. So how do I write all real numbers in interval notation? -infinity to +infinity, just like we said on the last slide.
Wait, how did you figure that out?
So just like we said on the last slide, if you don't have a fraction, if you don't have a radical, then your answer is going to be all real numbers, or -infinity to +infinity in interval notation. All right, next, the second part of this lesson, we're going to be evaluating the piecewise at the given function. So we have a piecewise function at the given value. It's going to tell us, so this is our f of x value here. It's going to give us a value for x. So for a, it says 5. We want to find the value when x is 5. So I need to see which of these 3 pieces of my graph 5 falls into. So first thing I need to do is look at the right side. The right side says this piece is what we look at if x is less than or equal to negative 2. This piece is what we look at if x is in between negative 2 and 1. And this piece is what we look at if x is greater than 1. So we're looking at when x is 5. Am I looking at piece number 1, 2, or 3?
3.
3, because 5 is greater than 1. So I'm looking at the third piece here. So we're going to plug in 5 into the x in our third piece. So I have 5 plus 4, which is 9. So the hardest part here is just figuring out which piece it belongs to. Next, we're looking for when x is 1/3. So is 1/3 less than negative 2? Is 1/3 in between negative 2 and 1? Yes. So we're looking at the second piece here. What's our answer going to be when we look at the second piece? 3. We don't even need to plug in the x. There's no value to plug in the x. Our answer is just 3. All right, let's look at C. So if it helps for C, let's figure out what whole number or decimal -9/2 would be. Awesome, -4.5. 2 goes into 9 4.5 times. So is -4.5 going to be less than -2? Is it in between -2 and 1, or is it greater than 1? The first one, it's less than -2. Oops, so we're looking at the first one. So let's plug it in. I'm going to plug it in as the fraction, -9/2 squared times 2 minus 3. So here we actually have to do some math. What do I do first? Make sure you follow your order of operations. We have to square it first. When we square a fraction, what do? Square the numerator and the denominator. So what's 9 squared? 81. Over 4. Perfect. Times 2. How do I multiply a fraction and a whole number? Straight across. You can make it 2/1, multiply it straight across. So this would be 162/4. Can we simplify 162/4? What goes into both 162 and 4? 2. So let's divide them both by 2. So we get 81/2 minus 3. How do I subtract a fraction and a whole number? Need a common denominator. So I'm going to change 3/1 to be 6/2. What's 81 minus 6? 75/2. Awesome. That would be our answer. All right, let's look at D. Talia. Which piece does -4 fall into? The first one. -4 is less than -2. So we're plugging it into the first one. So 2 times -4 squared minus 3. 2 times 16 is? 32 minus 3? 29. All right, last part of this section. Sometimes we're not only plugging in numbers into our function, sometimes we can also be plugging in variables too. So we just have to follow what it says. Here it gives us the function, so we have 3 times x squared plus 5, and it tells us we're going to plug in x plus 2 into the x. So I'm plugging in this x plus 2 into all the x's that I see in my equation here. So I have 3 times x plus 2 squared plus 5. How would I simplify? What do I do first? Boil. Awesome. This is like saying x plus 2 times x plus 2. I'm going to FOIL this out. So I have x squared plus 4x plus 4. What do I do next? Distribute. So 3x squared plus 12x plus 12 plus 5. Then what? Combine like terms. Awesome. 3x squared plus 12x plus 17. This would be our answer. All right, the one right below it, it's asking us to plug in two different things and then add them together. So first, it's f of x, just f of x, which is actually just this. We could plug in x into the x, but you get the same thing. So you don't need to do anything. F of x is equal to 3x squared plus 5. So we have 3x squared plus 5. The second part is asking us to plug in what into x? 3. So let's plug in 3 into x. So I'm plugging it into x. So we have 3 times 3 squared plus 5. What would I do first? Square the 3. So 3 squared is what? 9. And 9 times 3 is 27 plus 5. So we have 3x squared plus 5 plus 27 plus 5. Let's add our like terms. 5 plus 27 plus 5, awesome, 37. So 3x squared plus 37. So here it gives us a new function. What does it ask us to plug in first into x? 2x. So we're going to take 2x and plug it into the x's. So I have negative 6 times 2x plus 4. What's negative 6 times 2x? Negative 12x plus 4. Can I simplify it anymore? Nope. Our entire function f of x. So we take our function f of x. If we plug it in, we have 2 times f of x, which is negative 6x plus 4. So we're just distributing the 2 to it. So this would be negative 12x plus 8. Any questions here? All right, last part, the one on the bottom. What is it asking me to plug into x here? So our function is x minus 3. It's asking us, what does f of x squared equal? So what do I plug into x? X squared. So I take what's inside here and plug it into the x. So I have x squared minus 3.